Now, this is, you can simply pause the video and you can try to find out what is the problem in this ECG. Now, this ECG is actually very, very common, and we keep on getting this type of ECG very commonly. Now, when we try to see in lead V5 and V6, what we can notice is the R wave tallness. We can simply calculate the R wave tallness, which is 5 small boxes, 10, 15, 20, and around 21, and here around 3 to 4. So it is around 25 millimeter. So 25 millimeter is very commonly, if in V5 or V6, if there is 25 or more than 25 millimeter tall R is there, it highly suggests LVH, that is left ventricular hypertrophy. And why is that so? We must know, this is the x-axis, this is y-axis. Our heart, we have these two nipples here. So heart is usually present in this side or this area. So maximum portion of the left ventricle is around the left side. And when we place the leads, we know that V1 is placed here, V2 is placed here, V3 is around here, V4 is around here, V5 is around here, and V6 is around here. So the maximum portion of the left ventricle is around this area. So V5, V6, the leads which directly reflects the hypertrophy of the left ventricle. More is the left ventricular hypertrophy, taller will be the R wave. So less is the muscle mass, less will be the R, and more is the muscle mass, more will be the tallness of the R. That is the reason V5, V6, if it is whenever more than 25 millimeter, we call it as LVH. So this is very typical of LVH. And one more thing, as we know that there is so much muscle in here, automatically V1 will reflect a negative wave, because this simply negative wave means S wave will tell that there is significant muscle mass which is present over here. So in V1, what we can see is around 5, 10, and around 13 to 14. So more than 10 millimeter S wave in V1 and more than 25 in V5 to V6 is highly suggestive of LVH, and we call it as LVH. So there is one more thing that is usually associated with LVH. Whenever there is increased muscle mass, the R wave will automatically increase. That I told why. The second thing is कि more is the muscle mass, more is the time taken for repolarization. So this muscle will not very easily repolarize. It will take more time, so that there will be repolarization abnormality. And what is repolarization wave? It is T wave. So we must know T wave is almost positive in all the leads. But whenever there is LVH, this muscle mass is so much so that there will be a repolarization abnormality, and automatically this T wave will be a negative wave. What we typically refer as LVH with strain. So there is strain on the left ventricle. That is the reason why T wave is not positive. Repolarization abnormality is there. So we get a very tall R in V5 or V6 with the negative T wave. And you can see that T wave is positive here. T wave is positive here. T wave is positive here. So everywhere else, the T wave is positive. In AVL also, it is negative, because lead 1, lead AVL, lead V5, V6, they form lateral wall. So in other leads, the T wave is positive. The other leads, the T wave is positive. So typical tall R in V5, V6 with negative T wave, and a prominent S wave in lead V1. It is a composite component of LVH with strain. So this is very typical of LVH with strain, where there is more than 25 millimeter R in V5, V6, plus or minus, means it may be present or may not be present, more than or equal to 10 millimeter of S wave in V1, and typical of T inversion in again V5, V6, plus or minus lead 1 and AVL. So that's all for now.